Hello my dear students, welcome to chemistry classes. Students, in the previous videos we learned about the group 16 elements, means occurrence, atomic number and their electronic configurations and some of the important properties like electronegativity and ionization energy, atomic radii, ionic radii and melting point and boiling points, so on. Okay, and today I am going to tell you the next concept, that is group 16 elements, chemical properties and anomalous behavior and anomalous properties of oxygen. Okay students, here anomalous properties or anomalous behavior means here in group 16 elements like oxygen, sulfur, selenium, tellurium and polonium. Among these, oxygen it shows different properties. Than the remaining member of group 16 elements. Okay, so these type of properties are called anomalous properties or anomalous behavior. Okay, first I will write anomalous behavior or anomalous properties of oxygen. Anomalous behavior of oxygen. Anomalous behavior of, or you can say anomalous properties of oxygen. Students, here anomalous behavior means what? Anomalous behavior means oxygen shows different properties. Oxygen shows different properties than remaining group members, or you can say remaining group 16 elements. Oxygen it shows different properties than the remaining group 16 elements. So here the reasons are oxygen shows different properties due to the reasons, that is the first reason, small size of oxygen. Oxygen it has small size. Then second point, that is high electronegativity. Students, oxygen is the second most electronegative element in the periodic table. Small size of oxygen and high electronegativity of oxygen, and third one, unavailability of d orbital. Unavailability of d orbitals. Students, in oxygen there is no d orbitals. Okay, you can write oxygen. What is the atomic number of oxygen? H. Okay, the electronic configuration 1s2, 2s2 and 2p4. There is no d orbital present in the oxygen. That is why here, that is also one of the important anomalous behavior or anomalous property, unavailability of d orbitals. Okay, now three important anomalous behaviors are there. So in that, the reasons are, first one, small size of oxygen. This is the first reason to show anomalous behavior of oxygen. Second one, oxygen, it is the second most electronegative element in the periodic table. Okay. Then third one, unavailability of a d orbital in the oxygen. Oxygen, its electronic configuration is 1s2, 2s2, 2p4. There is no d orbitals present in the oxygen. Okay, now properties. ಹಾಗಾದ್ರೆ ಯಾವ ಪ್ರಾಪರ್ಟಿ ಇಂದ ನಾವು ನೋಡ್ತೀವಿ anomalous behavior. First one, oxygen is a gaseous in nature, whereas other elements are solid in nature. Okay, I will write here oxygen, sulfur, selenium, tellurium and polonium. Here oxygen is diatomic gas. These all are polyatomic in nature. Okay, and oxygen is a gas, whereas all the other elements of group 16 are solid in nature. And next one, students, here due to small size and high electronegativity of oxygen, it shows intermolecular hydrogen bonding. Due to small size and high electronegativity, oxygen it shows the intermolecular hydrogen bonding. And one more important property, due to small size and high electronegativity and unavailability of d orbital, oxygen it shows the abnormal melting point and the boiling point. Okay, and one more, oxygen it can form p pi bonding, whereas sulfur, selenium, tellurium, polonium they shows p pi d pi bonding. I will explain one by one. The properties means anomalous properties are, first one, anomalous property, that first one, due to small size and high electronegativity, oxygen can form intermolecular hydrogen bonding. Oxygen can form intermolecular hydrogen bonding. Due to small size and high electronegativity, oxygen can form a intermolecular hydrogen bonding. And second one, oxygen can form p pi bonding. Oxygen can form p pi bonding, whereas other elements of group 16 can form d pi t pi and p pi d pi bondings. The reason is due to unavailability of d orbitals in oxygen. Okay, oxygen can form p pi bonding, whereas other elements can form d pi p pi and p pi d pi bonding due to unavailability of d orbitals. And one more reason, third one, oxygen it shows maximum covalency. Oxygen it shows maximum covalency, that is 4. Maximum covalency, that is 2. Oxygen it shows maximum covalency, that is 2, whereas other elements can form like sulfur, selenium, tellurium, polonium, they shows covalency more than 2, like 4, 6 and so on. Okay, so this is also due to unavailability of a d orbital. I will explain it once. Due to unavailability of d orbital, oxygen it shows only covalency 2. Okay, and other elements like sulfur, selenium, tellurium, polonium, they shows covalency more than 2. Okay, and due to small size and high electronegativity, oxygen can shows abnormal melting point and boiling point. So this is about the anomalous behavior of oxygen and the reasons behind the anomalous behavior of oxygen. Okay, so these are the some points. And next one, students, chemical reactions of group 16 elements. Okay, chemical reactions, or you can say chemical properties of group 16 elements. Okay, here anomalous behavior of oxygen means oxygen it shows the different property than the group 16 elements. The reasons, oxygen it shows anomalous behavior. Some reasons are, first one is small size of oxygen, and second one is high electronegativity, and third one is unavailability of a d orbital. Okay, small size, high electronegativity, and unavailability of d orbital. These three are the main reasons to show abnormal behavior. In that properties, first one, due to small size and high electronegativity, oxygen can form intermolecular hydrogen bonding. So due to intermolecular hydrogen bonding, oxygen can show abnormal melting point and boiling points. And second one, oxygen can form p pi bonding. Oxygen only it can form P5 bonding, whereas other elements of group 16 they shows P5 bonding due to unavailability of d orbitals. And lastly, oxygen it shows the maximum covalency, that is 2, whereas other group 16 members they shows covalency more than 2. Okay, and next one, chemical properties of oxygen group 16 elements. Chemical properties of 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 group 16 elements. Students, here chemical properties nothing but reaction with hydrogen, reaction with halogen, reaction with oxygen, so on. Okay, like this here also group 16 element, when they react with hydrogen, what it forms and what are the properties, and when group 16 elements reaction with the oxygen, what it gives, and group 16 elements reaction with the halogen, what it gives. Let us check one by one. First one, reaction with hydrogen. Reaction with hydrogen. Students, here group 16 elements reaction with the hydrogen, what happens? So student, here when group 16 elements like oxygen, sulfur and selenium, tellurium and last one is polonium, when these elements react with the hydrogen, it can form a hydrides. Okay, alright. Group 16 elements reaction with hydrogen forms hydrides. It forms hydrides of the type that is H2E, of the type H2E. Simple, student, here when hydrogen react with the group 16 elements, it forms hydrides of the type H2E. Here E nothing but group 16 element. Okay, example I will write here. Example H2O and H2S, H2SE and H2PE and H2PO. So these are the example of hydrides. Water, hydrogen sulfide, hydrogen selenium, hydrogen tellurium, hydrogen polonium. These are the example of hydrides. Okay, now here some of the important properties of hydrides. They are first one bond length. H2O, H2S, H2SE, H2TE, H2PO. So among these, bond length is increases from H2O to H2PO. Bond length. Okay, and next one, reducing property. Here except water is in bit 2. Except water, remaining H2S, H2SE, H2TE, H2PO, this shows reducing property. And bond dissociation enthalpy is decreases from H2O to H2PO, and the acidic property also increases from H2O to H2PO, and thermal stability decreases from H2O to H2PO. Okay, I will write here. First one, bond length. Hydrides though only. Hydrides, you will hydrides. Okay. Bond length increases. Bond length increases from H2O to H2PO. Bond length is increases from H2O to H2PO. And second one, reducing property. reducing property increases. Reducing property increases from H2S to H2PO. H2S to H2PO. Here, water, it do not show reducing property. Or you can say, except water, all the remaining hydrides, they show reducing property. And next one, acidic property. Means here all are acidic in nature. Acidic property increases. Acidic property increases from H2O to H2PO. This is acidic property increases from H2O to H2PO. Okay, these all are about the hydrides only, students. Next one, bond dissociation energy is decreases. Bond dissociation energy decreases from H2O to H2PO. Bond dissociation energy decreases. And next one, thermal stability, it is also decreases. Thermal stability, it is also decreases. Thermal stability decreases from H2O to H2PO. H2O to H2PO. So these are the some of the important properties regarding the hydrides. First one, bond length increases from H2O to H2PO. Reducing property increases from H2S to H2PO except water. And acidic property increases from H2O to H2PO. And bond dissociation energy decreases from H2O to H2PO. And also thermal stability, it is also decreases from H2O to H2PO. So this is about hydrides and their respective properties. And students, next one, group 16 elements reaction with the oxygen. Okay, group 16 elements reaction with the oxygen. So here also say, when group 16 elements reaction with the oxygen, it forms two type of oxides. One is dioxide and the other one is trioxides. One is dioxide and the other one is trioxide. First one, group 16 elements reacts with oxygen. Reacts with oxygen. Group 16 elements reacts with oxygen. When group 16 elements reacts with oxygen can form two types of oxides. That is, first one EO2 and second one EO3. Here E is nothing but group 16 element. EO2 and EO3. Example O3, SO2 and PeO2 and PoO2. So these are the examples of when group 16 elements reaction with the oxygen. Here both dioxide and trioxide are acidic in nature. Both dioxide and trioxides are acidic in nature. Both dioxide and trioxides are acidic in nature. And next one, trioxides are more acidic than dioxide. Trioxides are more acidic than trioxides. Okay, so this is about when group 16 element reaction with the oxygen. Take it. Next one, students. Group 16 elements when they react with the halogens like fluorine, chlorine, bromine, iodine, and so on. Okay. So fluorine, chlorine, bromine, iodine, when they react with the group 16 elements, they form respective halides of the type EX6, EX4, EX2 and E2X2. Okay, when group 16 elements, oxygen irbodu, sulfur irbodu, selenium irbodu, tellurium irbodu, illa polonium irbodu. Okay, ಇವು ಯಾವಾಗ ಹ್ಯಾಲೋಜನ್ ಜೊತೆ ಫ್ಲೋರಿನ್, ಕ್ಲೋರಿನ್, ಬ್ರೋಮಿನ್, ಅಯೋಡಿನ್ ಇದರ ರಿಯಾಕ್ಷನ್ ಆದಾಗ ನಮಗೆ 4 ಟೈಪ್ ಪ್ರಾಡಕ್ಟ್ ಫಾರ್ಮೇಷನ್ ಆಗಬಹುದು. First one EX6, here E nothing but oxygen or sulfur, selenium or tellurium or polonium. EX6, EX4, here X nothing but fluorine, chlorine, bromine or iodine. EX6, EX4 and EX2 and E2X2. Okay, now stability of halides decreases in the order. Fluorine is more stable than the chlorine. It is more stable than the bromine. It is more stable than the iodine. Okay, stability decreases. It is in the order fluorine, chlorine, bromine, and iodine. And next one, students, among hexahalides, ಅಂದ್ರೆ EX6, among hexahalides, only hexafluorides are stable. Okay, EX6 type ಇರತಕ್ಕಂತ ಎಲ್ಲ ಹ್ಯಾಲೈಡ್ಸ್ ನಲ್ಲಿ only ಏನು hexafluorides are more stable. Okay, and next one, all hexafluorides are in a gaseous state. Okay, ella hexafluoride enu gaseous state ನಲ್ಲಿ present ಇರ್ತವೆ. Okay, and next one, they have octahedral structure. Okay, hexafluoride ಏನಂದ್ರೆ first they are stable, they are in the gaseous state and they have octahedral structure. So this is the structure of hexafluoride. Sulfur ಇದೆ, ಆಮೇಲೆ 6 fluorine atoms ಕೊಡಿದೆ. SF6. This is the best example for a hexafluoride. They are stable, they are in the gaseous stage and they have a octahedral structure. And the next one, SF4. Okay, SF4 is a gaseous in nature, SeF4 is liquid and TeF4 is a solid in nature. And these fluorides like SF4 irbodu, SeF4 irbodu, TeF4, these fluorides have a sp3 dehybridization. Okay, SF4, SeF4 and TeF4. Okay, these fluorides they have a sp3 dehybridization. And next one, trigonal bipyramidal structure. They have trigonal bipyramidal structure. So this is about the chemical properties of group 16 elements. Okay, when they react with the hydrogen, they form a respective hydrides. When they react with the oxygen, they form a respective oxides like dioxide and trioxide. When they react with the halogens, they form a halides of the